This video lecture is the conclusion of Hurricane Exercise Part 2, which we didn't finish in our last class before the spring break. So, as you may recall, we were working on analyzing the frequency of named storms in the North Atlantic as well as hurricanes and major hurricanes. We began with a data set that begins in 1950 and extends to 2019, although initially we only worked with data from 1970 to 2019, and that's important because you're going to be responsible for incorporating the earlier data as well. But first, let me recap where we left off. So we began by creating simple scatter plots of numbers of named storms and the number of major hurricanes, and then we added trend lines to those to see what's going on with those storms. And so in both cases we see what appeared to be trends of rising numbers of storms, both for named storms as well as for hurricanes and major hurricanes. So what we did next, and this is kind of where we left off, we were looking at adding a confidence interval around the trend line. And the idea here is that the lines, these trend lines, these red lines on the graphs in front of me, represent the best fit line through that cloud of points. And what that means is that they are sort of an average of the overall behavior of the points, and they try to model those points to see what's going on. But we always assume, or we always treat our data as if it's incomplete, sort of a sample. And so that trend line, we can't necessarily take it as gospel that that's exactly what it would be, that this is what's really going on. So if we treat our data as a sample, then what we're trying to understand is to what degree can we trust that trend line? How likely is it to represent what's really going on with storms in the North Atlantic? And so to get a sense of how well it captures what's going on, we want to add a confidence interval, which gives us a range of where that line could be if we had all of the data. So what we began was we took a portion of our data, again from 1970 to 2019, and we copied over the year data, just the years, and then we copied over the number of named storms for those years. So this is just a duplicate of the data over there. And then we added a new thing. We added the predictions, or not the predictions, but the trend values that are computed from a regression equation. And all of that is to say, it's the same thing that happens when you right-click on a set of points and you choose the trend line. What you're doing is you're asking Excel to compute a linear regression and what in it to generate that estimate of where that line would be. So the formula for doing that is called trend, and the trend formula will do essentially what the trend line function does when you right-click on the points. In this case, so it gives you the actual values that it's using to plot those points. This is an array formula, as you might recall, which meant that we had to highlight all the cells first before we input the formula to calculate it. This was a little of a pain initially to put in. But once we had that, we also calculated the regression statistics, which are these values over here. And these are what you might call diagnostics, but they're descriptions of what's going on with the regression equation that generates that trend line. And we did that because we needed all of this data in order to compute a larger, more complex equation, which was to do the confidence interval around the trend line. And this is where we left off in the class. So we were using this formula to compute the confidence interval, and the confidence interval basically is an upper and a lower value around the predicted or estimated value, which is what the trend line gives us. So we have a minimum value and a maximum value, and so this is what the equation looks like, and this is where we left off. We did it both for the minimum and the maximum values, and so with that we can build a graph that shows both the trend and the confidence interval. So I want to do that first as our starting point, and then I'll show you the last bit that we did not do in class that I wanted to cover. So again, just to be real clear, what we're doing is we're taking the data of named storms from 1970 to 2019, and we're making a scatter plot. So I'm highlighting the values for that, and I'm going to insert a new scatter plot. And so this scatter plot, let me drag it up here, is going to be what we're working from. Excuse me. So that scatter plot you're familiar with, we've already made this before, but now what we're doing is we're going to add the trend line. Now I could do that again by right-clicking and choosing Add Trend Line, and you see that familiar line. Let me make it a little more prominent. It's not that one, this one. There we go. Okay, you can see that trend line. But that line, again, is generated just the way these trend values are. So I can actually add those values just so you can see what that looks like. So I'm going to add a series to this. And you'll see how it works. I'm going to add the years. And then I'll add the trend line values. You see I've added a series for the trend line, and now what you have are those red dots. So those red dots represent these values in the predicted y column, or the y hat column. And so this again is just an estimate of the overall behavior of the points. It's a model for how the points are behaving in general. Now the question is, how well does that describe what's really going on? And that's why we did the confidence intervals. So they describe how well that line represents what's really happening. So I'm going to add those lines to my graph as well to get a sense of what's going on there. So it's the same process. I'm adding a series to that. So this one I'll start with a lower confidence interval. And again, it takes the same data that we've used before. The year data always represents the x values, and then the y values in this case are the minimum confidence interval values. So when I hit OK there, you can see that series added there. Let me just take a look at that. So you see that's that green thing along the bottom, right? One more for the upper confidence interval. So we'll do the same thing before. And then the y values, which are, again are these values. All right. So now we've got 4 series here, and our graph displays those. So you can see how those work. So let me move that chart to its own sheet. So you can see how the original trend line runs right down the middle of the cloud of points, and the confidence interval kind of creates a tube around the trend line, right? So what it tells us is that we're 95% confident, because that's what the confidence interval is based on. We're 95% confident that this trend line that falls somewhere within that tube between the purple dots and the green dots, right? Notice that in the middle it's kind of pinched there, or it's not. It's a little closer to the trend line, which means there's less error, or less uncertainty rather, in this area, because there's more data in this region, right? When you get on the outer edges, you have less data because you're missing stuff over here and over here, so it widens out. Okay, so what this tells us again is the confidence that we can have that the trend line lies somewhere in between these lines, and this particular one that we have here is one estimate of that, right? If we had a different set of data, or we had some missing data, we might look a little different, but we expect that most of the time it would fall within that line, within these two, the confidence interval upper and lower values. Okay, what we want to add now to this graph though is the prediction interval, and this is another tube that's going to go around this graph that tells us where we should expect another value, right? So when another storm happens, what's the range of possible numbers that it could take on, which is a different thing, because here we're talking about a trend line, right? Where's the real trend line? But the prediction interval is asking about individual years, right? How many storms should you expect in any given year, right? And that's what the prediction interval gives us. So to calculate that is a very similar process what we did before. So we're going to need 2 new columns. So I'm going to highlight the F and G columns and choose Insert to add in 2 empty columns. And so this is going to be our prediction interval. Okay, and it works the same way as the other ones. It has a min and a max value, and it's in fact identical types of formulas to these. So I'm just going to copy these formulas over. Okay, the difference is though that this formula adds a bit of error to account for the fact that you're asking for prediction, which is a much more specific bit of information. And whenever you're asking for more information, you're going to end up getting higher level of uncertainty. So in the formula, I'm going to add 1 plus over here, okay? And you'll see how it changes the number there. I'm going to do the same thing over here. Add 1 plus, okay? And that's all. So now I'm going to copy those formulas down, right? And you can see when you compare any two sets of numbers that they're different, right? So let's see what this looks like on our graph. So I'm going to add these two sets of numbers, these series, to my graph to see what it looks like. So that always works the same way. I go to select data and I'm going to add a series, excuse me. So this will be the lower PI, prediction interval. So again, we choose the year. And then the Y values, which will be the min they'll start off with. Okay. You can see that now the lower prediction interval. Add one more series. This will be the upper PI. Again, taking the years. And then the Y values will be the max values there. Okay. So now we have extra series on our graph, and these represent both the trend line, the confidence interval, 95% confidence interval, and then the prediction interval. So again, what the prediction interval tells us is that we can expect with 95% probability where any given year should fall, any particular value. So 95% of all values that we would expect, years with a number of hurricanes, will fall within that wider range. And you can see that most of the points fall within that range, but not all of them, right? Which is exactly consistent with what we expect. 95% of the time, any given year will fall somewhere in that range. So that's what we can expect. It's pretty wide, but it captures more of what's possible. But again, not everything. So the last bit we need to do with this graph is we need to clean it up again. So we just want to make sure that we know what we're looking at. So I want to add basic things like it should have a title. Let's see. All right, so this is going to be named tropical cyclones in the North Atlantic. This is 1970 to 2019. Okay. So because we have a variety of items here, we also want to add a legend to this so we know what those things mean. So one of the chart elements that you can add is a legend. Okay. And you can put it where you like it. I'm going to put it at the top just so it's more prominent. And so you can see that it shows the different items to it. We added both the trend line as a red dot here, and as also we added in the normal way as linear. I'd say go with one or the other. You don't necessarily need both. So that's what we're doing then. We're taking both the confidence interval and the prediction interval around our tropical cyclones. So what you're going to do, and which I'm not going to do, so this is up to you, I want you to recreate this same graph, but do it with the data from 1950 to 2019. Okay. So as a clue, what I suggest is that you start by making a duplicate of this page and then adding the data from 1950 to 1970 to it. You'll need to modify the formulas a little bit so that you're grabbing all of the data, but you should end up with a graph that extends from 1950 to 2019, and I think you'll see that it's similar in some ways and different in others. So that's what you're going to be submitting, and that's the last bit of Hurricane Part 2. That you're responsible for. So Hurricane Part 3 is covered in another series of video lectures online.